There's probably no better way, or cooler for that matter, to escape the police than to jump over a large traffic accident. This is exactly what Nicolas Cage does in the movie Gone in 60 Seconds. Being forced to steal 50 cars in one night to save his brother's life, Nicolas Cage's character Memphis Raines is seen here trying to evade the Los Angeles Police Department. When blocked by a massive pileup on the Vincent Thomas Bridge, Raines is faced with the decision. Does he stop and give in to the police, or does he attempt the most insane car evasion in Hollywood history? Watch what happens next. So this scene is very cool and very effective, but if accurate physics had been used, would Raines have made the jump? So as I said before, the bridge used to film this scene is the Vincent Thomas Bridge in Los Angeles. The distance between support beams on the bridge is 1,500 feet. However, since the ramp is past the middle of the bridge, we estimated that it was roughly 800 feet between the point where Nicolas Cage starts to accelerate to where he hits the ramp, thus making his jump distance 700 feet. The total time elapsed from point of acceleration to contact with the ramp is 16.18 seconds, and by looking at the speedometer we can assume that he is traveling at about 100 miles an hour, or 44.704 meters per second. By dividing the final speed by the time it took to get there, we can determine the average acceleration of the vehicle, which is 2.7629 meters per second squared. Now let's take a look at the ramp that Memphis Raines uses to launch his car into the air. Though there are no clear shots of the ramp to determine its dimensions, there is a truck directly next to it that just happens to be the same height. Upon further research, that truck is a GMC C8500, which has a height of 87.06 inches, or 2.211 meters. Also, if you look closer at this shot, you'll see that the car that Memphis Raines is driving is the exact length of the hypotenuse of the ramp, which is 186.6 inches, or 4.740 meters. Here is our ramp diagram using the dimensions we found. To find theta, we used the law of sines, which gave us a jump angle of 27.81 degrees. Using the speed of the Mustang and the angle theta, we can determine the x velocity and the y velocity when the car leaves the ramp. Then we can use a kinematic equation to figure out how long the car was in the air. Finally, by multiplying the car's velocity in the x direction by the time it was in the air, we can figure out how far the car would jump. While Raines would jump an insane 565.5 feet, he's still almost 150 feet short of what he would need to clear the accident. Now, did you happen to notice how steady his car stayed while it was traveling through the air? No rotation occurred whatsoever, and that's just blatantly unrealistic. By using the center of mass equation, we can determine that the center of mass of the Shelby GT500 Mustang is 2.067 meters from the front of the car. By using ratios of the length from the front of the car to the center of the mass over the length of the whole car, we can determine the weight distribution. By considering the car to be a particle, we can determine the rotational inertia. After solving for both the torque on the front of the car and the torque on the back of the car, we can determine the net torque on the car by subtracting the back from the front. Then, by using those two quantities, we can solve for the angular acceleration. Next, we need to solve for the centripetal acceleration, which comes out to be 0.606 meters per second. Finally, we can use that number to solve for the angular speed, which comes out to be approximately 30.7 degrees per second. By multiplying that speed by the time the car was in the air, then subtracting the original angle that the car was launched at, we conclude that the car would rotate 106.035 degrees counterclockwise from the parallel, landing almost directly on its hood. So not only would Memphis Raines fail to jump the 700 feet over the traffic accident, he would land on his hood, That would consequently end the police chase and send Memphis Reigns to jail. Here is a reimagined version of what the scene would look like with true physics. Lucky for Memphis Reigns, he exists only in a Hollywood movie. However, if this had been in real life, he might not have made it out so easily.